All right, hello everybody. Hope you're all doing well. Looks like we've got people from all over the world here. This is kind of exciting.
Yeah, hey everyone.
My name's Chris. I'm a freelance lighting designer, and we have.
I'm Jim, the product designer here at RC4. Some of you guys are here I've met several times, so although I can't see your faces, it's great to see that you're here. Thanks for coming. And we're really looking for questions and participation, so please help us out with that.
Exactly. So we have Anna, who is moderating the chat for us, and as you ask questions, Anna will curate those questions in for us to answer as we go through things. We have a few things we're going to show you along the way here, and like I said, and Jim said, please ask questions. This is really focused on being a Q&A, and it's our first live stream ever, so this is exciting. It's really weird being on this side of the camera. One of the first things that we want to mention here is that there is a new version of Commander out, and there's been some substantial changes with Commander. And I'm going to bring it up here.
I don't know if we've got our software developer in the audience anywhere, but Dave has been putting a lot of life into Commander and really livening it up a lot with some really great ease of use stuff. So some really nice work there for sure.
Jim, do you want to mention some of the new features?
Well, I really wanted to emphasize some new servo motor stuff in here. So for quite some time now, many of you may not even know, but we've had 8-bit control of servo motors for a long time. We've added some really neat stuff more recently that lets you set the range sort of to be able to narrow it in or widen it out a bit, depending on what the range is of the physical motor or the manufacturer that you've chosen to use. But the other big deal that we're able to show today is 16-bit control. So now you're using 2 ganged channels and getting, so now with say 5-turn motors and linear actuator motors, things like this, where a finer resolution than 256 steps is really handy, we can do that. So it really works the same way as the curves did before. I don't know, Chris, if you can click on a curve selection there. But
and I just made the realization that I updated Commander to be the most current version that's on the website. And in doing so, I don't have the servo stuff on here.
Right.
Because it's currently in beta.
It is, yes. And so is the firmware. Oh, I see Dave just joined us too. So that's great. If you have specific questions, he might, I didn't talk to him about this in advance. I should be careful what I offer, but he might want to maybe chat with you guys also. So yeah, the list of curves, actually, if you just pop up what's there, you'll see the original 2 that were for motors clockwise and counterclockwise. And now there's just 2 more options in there that let you do those 2 choices, but with 16-bit control. And as is typical of, say pan and tilt in a moving light, it becomes 2 tandem channels to give you the 16-bit control. It's very intuitive in that respect. So it's very straightforward. Do we have an opportunity, Chris, to actually show the wiring of how that works, of how to, because I get a lot of people that are confused about how to actually connect the motor. Like how do you connect a motor to a dimmer?
Yeah, definitely.
So yeah, the trick here that I'm really kind of proud of in firmware development is I was able to make a regular lamp dimmer output the pulse signal that the motor wants to see. So if you connect it to a lamp in that state, it just kind of looks like it's always on at a dim level. It's a little bit of you might perceive it as an anomaly or an oddity, but in fact, it's producing what these motors want to see. So what we normally do is power the motor from the same power supply as the dimmer, but just wire directly. So usually you've got a red and a black motor, red and black wire from the motor, and you'll connect those up to your battery or your power supply. And then the negative terminal of a dimmer becomes the data signal. So often on the motors that you buy, that third wire is yellow or orange, something to distinguish it from the black and the red. And so it's the negative terminal where the data appears on an RC4 dimmer. And that it then controls, just like you're seeing there. Chris has his elevator indicator set or prop.
And so this is running 16-bit for the servo control, and it's actually using a 5-turn servo in there. So it's whatever 5 times 360 degrees is. Math is hard right now. That's the number of turns that this servo can do. And with the 16-bit and which we'll mention also in a moment here, a new servo range function, we can actually truncate that movement down to fit better within this structure here. So now that I've showed that, let me disconnect it so we can take a look.
Yeah, that controlling the range has turned out to be a pretty big deal. There are servo controllers out there from the same people that make the motors that let you tweak the low end and the high end or range and scale. I've decided to go with the scaling method because my thought is you can build your machinery and for the prop, could be wiggling ears or mouths that open, whatever it might be. And you'll know what the range is. So you can clamp the motor shaft on at whatever end is the end of travel. But then you will want the full extreme of the control to stop wherever your machine needs it to end. And that's not always going to be the full range of whatever motor it is that you chose to deploy. So what we have now in the new Commander that Chris isn't showing you right now is the ability to set that scale level. And that's an 8-bit level, so it goes from 0 to 255. And when you set it to the widest, well, for reference, the classic servo motor range in signal width is described in milliseconds of pulse. And it's typically 1 millisecond is extreme in one direction and 2 milliseconds is extreme in the other direction. Kind of arbitrary. Those aren't numbers you ever have to remember. But for reference, some of the wider range motors, they've gone as far as moving that 1 back to half a millisecond and pushing the 2 up to 2.5. So that it's actually a substantial increase in the pulse range that's available for telling the motor where to go. So what we've done now is given you the ability to basically map out that range. So you can go all the way out to the 0.5 to 2.5. Or if you're doing something like a mouth, it might use just a very small fraction of a rotation. You could run that all the way in and give it a range of only a few degrees. So you're not bound now to try and find a motor that gives you that range or have to put gearing on it or scale it from the console, all of those things that scaling from the console is an easy solution, but sometimes if you end up with the console cleared, with your patches cleared, you could end up sending a not scaled signal to that motor and potentially break something in your prop. So I prefer the idea that when you've built the piece, you want the controls and the limiting and the scaling to be in the hardware that's in the box, like we're looking at here on the back of the elevator piece. So now, no matter what DMX controller you hook it up to, there's or certainly you've vastly reduced the likelihood of some rogue signal, a channel moving that was unexpected and goes to full level, turning a shaft too far. So the ability to control that is a big deal, I think.
And what you can't see on this is this has already been shattered once. Because I had before the most recent update, this 5-turn servo, I had it set up in the console and having limits within a curve. So it would go at 30% would be here. So 0% on the console would be 30% of the movement. And then 70% was over here. Well, unfortunately, I had did a show, came back, had to reload the show file, and I lost my curve. And so my needle went all the way around and tore the whole thing apart. Now with being able to set the range on there and also having the servo motor activation point, which we should mention, Jim, really protects the stuff that we put it in. Wiring wise here, sorry, it's kind of a mess. We have our DMX4 DIM, which is part of the Magic 3 series, 2.4 gigahertz. That we have our power coming into it. So I have a main power line coming in. It's coming to some Wagos acting as a bus bar. Our power is coming in. We're only hooking the signal line up to the negative of the dimmer that I want to use. And that dimmer is currently set as clockwise 16-bit servo. And then the negative and the positive for the servo are actually running up to the bus bar up here. And that way it can divvy out the power. The nice thing is, and I've used this quite a bit in this function, you could have dimmer A be your servo, and then dimmer C and D, if you want, be LEDs inside the thing that you're moving, which is quite useful. There's a video that you'll see pop up on our YouTube channel of Harvey. Harvey's our animatronic eyeball that basically is a product of the pandemic and losing all my shows, not knowing what to do. So I decided to learn how to do animatronics. And I know a light board well. I don't know radio transmitters for like the planes as well. So I decided to make Harvey controlled from the light board. And we had a 4-dim that did the eyelid movements, and it does the pan and tilt of the eyeball, which worked out really well. Then we have a DMX Pix over here, which is driving the 170 LEDs that are inside the unit, the pixels within there.
I think, does that award you asked, what is the device to the right? Is that, I think that's what you mean, the DMX Pix. So right now, the devices that we're seeing on screen are RC4 Magic devices. Yes, everything that you're seeing today, regardless of which product family we're demoing for any given piece, what I have now for years called RC4 Harmonized Design means when I write a firmware function, that code is then compiled into all the different device families. And as much as possible for the hardware, they behave identically. So in the case of Lumen Radio, so if I add it to the 4-channel Magic dimmer, in the same way, those functions will appear in the 4-channel Lumen dim devices. Another nice thing there too is the RDM support that crosses all the families. So in some cases, we might be talking about using RC4 Commander to configure a device. But if you're using a Lumen dim product, then you can do it with RDM, and it's a familiar interface for you there. It's not as graphical, so something that I really like about being able to work with Dave in custom software for us is you can often see something that is a little bit more representative of the workflow, whereas RDM tends to be lists of parameters and their values, so it's sometimes a little bit more abstract. But nonetheless, all of the features are there and accessibility to them is there, so no concern about whether or not your device can do it, other than it has to be Series 3, which still counts for hardware all the way back to 2013. So that means if you bought a Series 3 device in the middle of 2013 or any time after that, today's firmware will still load in that package.
We have another question here. So scale isn't based on the midpoint of the range, right? You could make your range to be, say, 1.5 milliseconds to 2, for instance.
Right. So that's where I was saying I did decide to scale it to the center. And although we have, of course, I can do an update if it turns out there's a lot of feedback to do it a different way. But my thought is you're always going to have the mechanical connection from the motor shaft to whatever your machine is. So the reference point becomes kind of mechanically arbitrary. Say it's a set screw on a shaft or something like that. You can set it to wherever it is physically the range. So all you really need to be concerned about is that you're getting the right number of degrees. If that turns out from user feedback to not have been the best approach, then sure, we can change it to be what the bottom end is and what the top end is. But I've found for all motors that I've bought and tested, they've tended to be based on that 1 to 2 millisecond range, and they do tend to expand out in both directions. So I haven't yet encountered a manufacturer where they added range by only making the 2 higher but having the bottom at 1. I suppose if that happened, then it might do us well to add the ability to tweak the top and the bottom. But the advantage of the method we use now is it's only one parameter you have to worry about.
We have a question here. Which RF frequencies did you choose?
So I guess, so do we mean RF bands? Because we do make systems that are 900 megahertz and 2.4 gigahertz. 900 megahertz Magic is very, very popular in Canada and the USA, Australia, New Zealand. There are a number of sub-country jurisdictions. We have discovered that you can use 900 megahertz with some configuration constraints in Hong Kong, for example. And I saw we have someone from Hong Kong today. Thanks for coming. It is because I don't live and work in the Hong Kong jurisdiction, and sometimes there are language barriers. Have not been able to exactly decipher what the restrictions are and where you can and cannot use it. But that certainly, if anyone in that part of the world can help me with that, we can work with you, and we have a lot of flexibility with that stuff.
And with specifically the elevator project, I am running actually, you think, two. Let me double check. I'm running the Series 3 2.4 gigahertz range is what I'm using for the elevator project. And we have a lot going right now. We have over here for Joseph's coat, that is running Lumen Radio set up on that. So we have 3 DMX Pix micros based out of Lumen Dim range.
That are the Lumen Dim Pix micro.
Lumen Dim Pix, thank you.
Yeah.
And then, which I forgot to plug in, I have an orb over here that is running the 900 megahertz series. That was on. This is the prototype for a version that was on stage for the Magic Flute. Personally, when I'm designing shows, if I am going to put a wireless device into a costume, I tend to go with the 900 megahertz series if I can, just because it gets through bodies a little bit better. And I have a little bit better reception in terms of that. In terms of props and other things, if it's not a long distance, I go with the Series 3 2.4 gigahertz equipment.
I know we've got a lot of European visitors here today, so I probably don't really want to focus too much on an RF band that many of you are not legally allowed to deploy. But some of you will be working worldwide also. So if you're working on projects that will end up produced in Australia, for example, or the United States or Canada, you could think about the 900 megahertz band. I will say that the advantage that we have with 900 megahertz, when we first introduced it, we were the only people using it for wireless DMX. We do have one competitor now, but there is a significant difference in our output power. We can transmit with 250 milliwatts of power, and that's for the RC4 Magic system. That is the same price as our 2.4 Magic system, and because of the propagation characteristics of lower RF frequencies, the range, if all else is identical, the range at 900 megahertz is about double what you get from 2.4. But then the FCC and the equivalent regulators for the other jurisdictions, which are fairly well harmonized, meaning their regulations are fairly similar, we are allowed to run at significantly higher power than we're allowed to run at 2.4, and that doubles the range again. So basically, all things being equal, 900 megahertz dropped into the same set pieces and props and so on will give you 4 times the distance, 4 times the range. And that is physical range too. I want to distinguish and differentiate that from RF power, because the relationship between power and range is not linear. You need about 4 times the power to get twice the range. So these are, it's much the same as light. It's the square law. So, and sound also too. So as you get farther away from the source, the dB power level is dropping off on that more rapid curve. So also consider the flip side of that. If you can get a little bit closer to a transmitter, your signal improvement is dramatically better than, whatever the linear difference is. So if you were 200 feet away and you can move up 20 feet, you are getting vastly better than a 10% improvement. So I just don't want to talk too much about a band you may not be able to use, but some interesting stuff to keep in mind there too. I will say all of the things that I said about 900 are reversed when you go above 2.4. So if we go up to 5.8 gigahertz, 6 gigahertz, 5.2, 5.3 are available in some areas. We don't make products that work in those bands, but you have the antithesis of the benefits of 900. You end up having shorter ranges and more difficulty breaking through obstructions and barriers. And in some cases, also lower power levels that are allowed at those higher frequencies. So then that further diminishes the range that you can get. So right now, the 900 and the 2.4 are most popular for wireless DMX for some fairly solid engineering and performance reasons. That they're all related to what you can do in a crowded theater where your prop may have devices and antennas inside, something of considerable mass. So we really want the signals to be able to get through that.
I see SBS Lighting mentioned that 900 megahertz for the win on our prompter lights. Yeah, I use 900 megahertz for Q lights all the time because it cuts through all those concrete walls in the theater building, getting from wherever you got to go, getting up on the rail and whatnot. It's been pretty fantastic. And I've done shows where the lobby has had to be interactive with what's actually happening on stage. We had lighting installed out in the library, and we were able to out in the lobby. We were able to use 900 and make it all the way through the theater, the concrete, steel, and everything. It was pretty incredible. We got wrong button. We have a question here. Yes, but it's also messing band. Not so much any longer in North America, but is it worth keeping that in mind?
So you mean the 2.4 gigahertz as being certainly unquestionably the most congested band? Absolutely, it is. We can't ignore that. That is a fact. But we also should keep in mind that all of the designers, including us, are taking this into account. So, our abilities to work around one another and in some cases self-manage. The very optimal way to manage a big show. And I will see that of our customers, the people who run Madison Square Gardens and Radio City Music Hall really did it first, in my experience. There might have been, they have done a really fabulous job. I'm going to say almost from day one of recognizing that they've got to think about everything that's wireless in their facility, kind of on both sides, the stage stuff and the house stuff, and know what bands they're using and manually configure for the optimal way to keep signals of those different devices into the pieces of the bands in a very well managed way. And I don't recall getting a tech support call from Madison Square Gardens ever, which is that's something to say, because I'm pretty sure it's pretty exclusively RC4 stuff in that house. And it's the same manager for Radio City, so it's the same deal there. Just looking at the questions. Sorry. Do we see?
No problem. While you look at the questions, I'm going to mention. So recently, I had a production where we were running 6 or 7 DMX IOs in the 2.4 gigahertz range. We had 7 universes of wireless built into the show. Some of it was running the coat, which has 500 RGB LED pixels inside there. We had set pieces that had to move that were also wireless. In Magic Flute, we had a ton. Ooh, I'm gonna knock everything over. We had a ton of orbs that were 3D printed that had these inner cores that had these pixels in them, so we could animate around the orbs. And with that much radio transmission, there was a cell tower on top of the building. There was sound. There was a heavy Wi-Fi installation for the 1,500 people coming in the house. It was a rock solid system. That was what took a lot of the pressure off of trying to implement something that large and complex within there.
Eric has yes. Hey, Eric, thanks for coming. It is frequency hopping for our 900 megahertz device, which is an important distinction because we don't use frequency hopping for our 2.4 product. And this has to do with how much bandwidth is available and what the optimal radio techniques and technologies are given the space that's there and the power that we're allowed to use and so on. But we do give you a lot of flexibility for what is really called channel masking. So we take the band and divide it up on the RC4 Magic system. We divide it up into 64 sub channels that go from 915 to 928 or 902 to 928, where 915 is the middle, 915 megahertz. And you need at least 25 of those channels to be active in the hopping process to ensure that we meet FCC requirements. So the way FCC works, they let you do higher levels of power if you can assure them that you're not on any given frequency for longer than a certain time, and that the number of channels that you jump around in are wide enough that you don't come back to the same channel too often. So for the power that we're allowed to do, 1/25 of the time is the minimum. And so that leaves 25, that's 25 out of 64 channels. And unlike many systems, you can choose exactly which of the 25 you want that to be. So if you wanted it to be just the bottom of the band or just the top of the band, you can do that. But even more intriguing, you could do, say, every other channel or something like that. And so this also lets you do multiple universes while minimizing or actually completely avoiding interference between the universes. So for instance, you can have, you could use every other channel in even numbers on one universe and every other channel in odd numbers for another universe. And keep in mind that with all of the hopping going on and a lot of error checking and so on, if occasionally two systems land on the same channel for a very short period of time, there will be data corruption at that time, but it's so short that it really doesn't matter. You have to have a lot of file collision, data collision, before it's anything noticeable, even with test equipment, never mind your eyes. Your eyes are actually much more forgiving than the test equipment. So the idea there is if you want to use your wireless e-stop system, that's fine, as long as it also gives you the ability to curtail which parts of the band it uses. And I found there's a lot of products in the field where early versions of firmware didn't give you that. But if you haven't checked lately, maybe go and see if the manufacturer of that system has opened that up, because the demand for the ability to manually manage, like I was talking about earlier, the demand for that is high. So it is really, for designers of anything wireless, the more flexibility you can provide for that managing the interactions, the better your systems, all of your systems will be. So you'll often have that flexibility. So let's continue that conversation separate from this, but yeah, I'm happy to help you with that.
DVDA says, love the lighted orb, Chris. Reminds me of the classic Star Trek. Yes, that's where the inspiration came from within there. Yeah. It's a 50 RGB pixels in there, so it's 150 addresses per orb that we had on stage. But it allowed, as the witches were doing their thing, us to create animations and send video content wirelessly through the RC4 system to give us this energy and motion with inside there, and works up pretty nicely. So
yeah, do a little how-to, show the pieces.
Yeah. So this is because budget was a concern with this production. This is your Amazon basic. I think it's actually Alto pixel tape in here. So it's just RGB. This is PET-G printed on a printer. There's a gyroid infill inside of it, so it helps disperse the light a little bit better. And it's got a texture on the outside, so it helps them grip a little bit better on stage. Then there was a bottom plate. And then all electronics just pops out. Then there, so you have the DMX picks, and then the battery there. It's running off a 6-volt battery right now. When we designed this, RC4 had not announced their new DMX picks micro. which that would have been awesome to have when we designed this, because it would have made it a lot smaller and was able to make it a little bit lighter. And that actually came out midsummer, I think, right? So the DMX Pix Micro, which is new. There we go. There's the camera going to focus to it? Hopefully. So that gives you a sense.
That's the LumenDim.
LumenDim, yeah.
Yeah.
And I think, I don't remember if it's actually in a prop right now next to me. Oh, wait, here we go. Yeah. So this is the 2.4 gigahertz version. This is the LumenDim version.
Right. So the black one is RC4 Magic, and the white one is Lumen Radio compatible.
And the best part is the size. It's this the Magic series. This one has the external antenna on it. You can get it with an internal antenna, so you don't have to have that. But if you're putting it on a prop that is metal or something like that, it's nice to have this external antenna to be able to get better signal in and out.
I always like to fall back a little bit, like restate some of the features that are in our pixel dimmers too, because they're really there are still no products like this. There's 2 pixel drivers that each will do up to 500 pixels, which of course is much more than a single universe will control in a 1-to-1 ratio. And the way that we've done that is our patented custom pixel profile system. So what we've done is what we've recognized. For instance, if you look at what Chris has there running in the background of the elevator, that effect could be demonstrated or realized with a very large number of pixels, but the core of the effect, the pattern of it, can be defined in a relatively small number of channels. And that's how you've been doing effects programming on your console also. But then to control all the pixels, the console is doing what I would call the rolling out of the data, the repetitions, the repeats, the sort of fractal element of it almost, where you've got a core representation of the look, but then it has to be multiplied out over a given range. So what we've done is we've moved that function from the console into the little tiny RC4 device with a short list of parameters that you configure either with RDM or with Commander. And so now your console is only outputting the little snippet that I call the keyframe that gives our software everything it needs to know about the look. And it really, in many, many cases, ends up to look the same as what the console was doing. But when the console does it, it's burning through multiple universes to do that many pixels. Because remember, you can hook 1,000 pixels up to that tiny little board that was in Chris's hand a moment ago. So when the dimmer does all of that extrapolation and multiplication work, now you've got a really big, beautiful display, and potentially multiple ones with different looks that you've designed yourself. So you haven't chosen from a library of preset effects that we thought you might like. You're saying, I'm going to use a third of my universe for this one. And for this other one, I can do it with 32 channels because it's a very simple, maybe a marquee effect. Classic marquee, you could do with 9 channels and just have it repeat all the way around a proscenium effect. So just you now can take that one universe and fill it with all these different keyframes and then distribute those out to all the different props that are doing their own fades and moving at their own speeds and having all their own looks. It's giving you all of that control that you like to have. All we've done is move the replication part of it out of the console and therefore reduced how many channels you need.
And the flexibility. So for my designs, I've found I'm starting to switch to using pixels more and more because of the flexibility. If I have a fireplace, I'm putting pixels in the fireplace so I can create animation and movement and things like that. A couple test cases. So the coat for Joseph, we wanted to have specific animations playing across it. In fact, we are using MTEX Elm that is sending out SACN to the Stardust from Lumen Radio, and that is going to the Lumen Dim picks that are inside the coat. There's 3 of them in there. And so we're actually able to send real-time video content to the coat by using Elm to do this. It works really well, but we need to be very specific. Of course, I'm eating up 3 universes of data in order to do this. When I recently did White Christmas, we had a ton of Christmas tree lights strung all across the stage and whatnot. We wanted them to be pixels, so we can animate across. We can do regular Christmas tree light effects. We can make it kind of gradiate color from blue to silver across the entire stage. We didn't have the data structure to be able to do every single pixel independently. So we were able to set keyframes inside the DMX picks, same technology is doing that. And instead of using, I think it was going to be 8 or 9 universes, we end up using 3, something like that, 2 or 3, by using the replication method in there. So this little box will replicate out for you your data to whatever, either by grouping pixels together or repeating the data in any way that you want to repeat it, out to 1,000 pixels. So one universe can do 1,000 pixels. That has been very powerful and very useful for a lot of stuff I've been working on. And I'm using it more and more, especially now with the micros, because I can stick them in things. There's
I just want to say, I mean, we do know that it's. I feel like the learning curve has been the barrier for people picking up and using this. It's not very many parameters, really. It's quite straightforward, but wrapping your head around how exactly it does this has been a challenge, both to describe from our end and for the users to absorb and understand. But it's so worth it. There's
so
just
I have a question.
The power that you can get from this.
I have a question for the chat here, and hopefully you can give us feedback on this. So I've been working on tutorials for the DMX picks, and they're long because there's a lot going on in there, and right now they're boring. And that's why it's taking me so long, is because it's dry and boring. Would you all be interested if we did a live stream where we can go through on how to set up a DMX picks, how to utilize it, and you'll be able to ask us questions in real time as we go through that? Is that something that people would be willing to attend and watch, as opposed to watching me poke up buttons and turn things on and off, in a non-interactive fashion?
So Chris actually means something that's much more specific how-to. Like, we'll have the RDM controller on screen, be manipulating the parameters, talking about what each parameter does, and see the difference. So yeah, it's a little bit less big picture and more focus on a particular outcome.
And we can look at the different kind of pixels, like WS2812, 11, that range, versus HD 108. Getting it when you get into, correct me if I'm wrong, Jim, 16-bit pixels, 16-bit dimming with the HD 108, that type of stuff.
Yeah.
Looks like people think it'll be useful. So we'll start thinking about that and put it together, because again, the DMX picks is become my go-to for fireplaces, fire pits, animations, things that I need to create life in there. Yeah, as soon as I can afford 16-bit pixels, I'll be putting in more things because it has a better fade. Keep in mind with WS2812 in that range, 2811, it's only 8-bit dimming, right? Am I saying that right, Jim?
That's correct.
That's in the pixel itself, right? So that's the pixel itself. And so it's just kind of, it's, chunk. When you're dimming quickly, and it's not a noticeable thing, right? You're fine. If you're doing flashy things, like back there, and over here, you can hardly notice that it's stepping. But when you have long fades, that's when you're really going to start to notice it. I've got a production of Macbeth coming up here, where we have 10-watt pixel floodlights built into the stage deck everywhere. And I have to take into account that they're great floodlights. They got great color. They're bright, but they're going to step when I fade them. And so what I do is
early LED fixtures all behaved, and the very first ones that came out and were all very choppy at the bottom.
And the way to get around that is to hide your fade amongst everything else fading, right? So I'll part out my cue so that all my moving lights, my LED, my color sources or lusters, and my conventionals are all fading and holding just for a moment, while my pixel floodlights are disappearing quicker within a separate part. That way you don't notice, because all the other lights are washing out that stepping on the final portion of the fade. We're sneaky at hiding things across there. Pixels, they honestly they're making everything so much easier to manage, and especially complex systems. And we have the capability.
You mentioned the HD 108.
Yeah.
Many years ago, we supported another 16-bit pixel that has been pretty much impossible for anyone to get. And now the HD 108 was also difficult to get for a while, but it sounds like it's a little bit easier to find now. Important to not confuse it with the HD 107, which was a predecessor and is not controlled the same way. I have samples of it, and it's on the to-do list to add that to our support also. But right now, right out of the box, the HD 108 is a 16-bit pixel that doesn't have that low-end choppiness. It is they deliver the most visually appealing dim of any pixel I have ever seen. We've done it. We've actually deployed the same technique that we've used in our regular LED dimmers for the HD 108 and the pixel driver. It's still 8-bit control from the console end, and we do the square law dimming curve to the 16-bit capacity in the pixel. So now we're not using up any additional DMX channels, which is the downside of 16-bit target devices for anything wireless, because obviously if everything is 16-bit, you can only do half as many of them in a universe. So we found that happy medium with the HD 108, where on the console side you're still doing it 8-bit, but by giving you the really good curve that's in our RC4 dimmer, you get the advantage of the smooth bottom end without having to waste twice as many channels. So I definitely recommend looking at the HD 108 and comparing the look, in particular if you need the low end quality to be really nice. Another area where you see that, I'm sure this happens to you, Chris, where you've designed the prop and the way it fits in when you're doing tech or whatever, the director wants you to have it at half brightness. Something where, or it's doing, as you said, a very slow fade. Maybe the entire piece is coming up very slowly. And when you're down in the bottom end of an 8-bit dimmer, what looks beautiful up in the bright ranges looks very choppy and steppy when it's dimmed down. So these are issues that go away when the dimmer that's built into the pixel itself has that additional resolution. So yeah, the HD 108, 65,565 steps of levels are in each chip that is making the light. And so that's the data resolution that we can send to it. Whereas all the other ones have only the 256 steps and they're linear steps. So at the bottom, they don't look all that great. And you know exactly what I'm talking about, because every pixel you've probably used is one of those. It's all of them except the HD 108.
Speaking of resolution, so an example of being able to drive things that are powerful with small things. I want to thank the University of Nebraska Omaha for letting me borrow this. This is a fire pit, the bottom of a fire pit, campfire. That's the right word. For a production of Men on Boats. And so you got the logs built up and everything around here. And in that production, needed to be able to light people sitting around the campfire as the primary light source. And so you need to have a whole lot of umph within there. So what we have is a 50-watt LED. Yes, that is a 50-watt LED within here in the system. We have 3 batteries, and then it was originally designed for the 2-dim, and because we didn't have access at the time to the micro, but for this purpose I put a DMX Pick mic or a
Lumen
M2 micro in there.
Right.
And so the way we have set it up is this 50-watt LED will melt itself. I just turn it on by itself. It draws way too much heat. The amperage shoots up when you do that. So we have to have a cooling fan built into here also. Within the M2, we have dimmer B, so the second dimmer, set as a non-dim, and that's controlling the fan. And in the console, I have it set up that it is within its own channel. And then we have the LED on dimmer A. So anytime that we turn on, let me turn it on here. We want to use the LED, we will turn on the fan. There's a radiator on the backside, a cooling system, pushes the air through. So the LED can be cool. And then let's see how mad my camera is going to get. That's 10% right there. That's full. The nice thing about having the fan on a separate channel that's set as a non-dim, I can break that fan into a separate part. So when we go into a scene transition, heading into another scene where this is not being used, I can set that part where things are fading out so that it will stay on for 2 minutes, continually cooling the LED down, and then it will turn itself off after that amount of time. A good way to maintain the quality of your stuff you're working with, and it's not too expensive again to work with. Basically, the way the wiring set up here is we're just splitting our voltage off. So the DMX, the Lumen Dim M2 is getting 12 volts. The fan's getting 12 volts, and the LED itself is getting 36. Well, with the resistor, it's technically 34, and so it's being dropped down with the resistors there. Obviously, put a fuse in for safety and all that. But it gave us a lot of flexibility to be able to light an entire scene with just one point source within there. And yeah, do you have anything you want to add to that, Jim? Oh, I forgot the resolution I was going to mention, 19-bit dimming, which is what gave the ability that, yes, this is small, but this is able to handle dimming a 50-watt LED, and it's still 19-bit, so we can get really smooth all the way down. As the fire there's an entire long sequence where the fire starts to, the campfire starts to die out, and it has to slow its flicker down and all that.
Yeah, the thing that you've sort of hinted at here that gets a lot of attention is the multi-voltage thing. A lot of people have not realized that, for instance, the dimmer might need to. Many of our dimmer products will only run down to 5 volts, but you might have, say, a 3 volt candle flicker effect or something like that. Or on the other direction, you might have a higher voltage device or multiple devices that you need to control from a single dimmer. Maybe something that runs at 6 volts and something else that runs at 24 volts. And you can do this. Chris has done a series. How many are there, Chris? Like 3 different videos that approach this problem?
We are at 3, and we're about ready to add a 4th for this one.
Right. It is. Keep this in mind. If there's sort of one thing you didn't realize you could do with an RC4 dimmer, it's run each individual dimmer with a load that operates at a different native voltage, and it's the single dimmer device will do them. The trick there is that they dim on the negative side, and all of the negatives on the power supply are the same. So you can have a positive that's high for, say, a 24 volt battery that goes to a 24 volt lamp, goes to the negative side of a dimmer, and that will work fine. And you might also have a 6 volt motor that you want to run that's making a whirligig go around, and you can have a 6 volt battery go to that, and the negative side will go to a different negative dimmer on the same dimmer device. And now you've got 2 dimmers side by side. One is running a 24 volt device, the other one is running a 6 volt device, and they work perfectly as you would expect them to work. You could even run the dimmer on its own voltage and all of the devices on the dimmer outputs on other voltages of their own. The only requirement is that the common ground is there between all of them. So the negative is all the same. Just so the ground is always the same, and the different supply voltages kind of stack up.
And we have a
great
question
trick to keep in mind. Does
all the LED current flow through the RC4 device?
Yes, it does. For the purposes of dimming, it is a circuit where on the negative side, the dimmer is managing. The dimmer is the dimmer. Yes, all of the current flows through the circuit. The switch dimmer device is the RC4 device.
And there's a benefit, correct me if I'm wrong, Jim, of running the positive directly to the battery coming from the LED versus connecting it to, let's say, the 4-dim or 2-dim.
Yes. Another good tip to keep in mind, and again, this applies to all RC4 dimmers, because all of the dimmer action, if you will, happens on the negative side. internal to these devices, the plus terminals are all just connected together. But it's copper traces on a circuit board that are basically that wiring inside. And if you're running very, very high currents, it helps if you don't run that current through an otherwise unnecessary little piece of copper trace on a circuit board. It makes more sense to just run the positive side right back to the power supply that is the source of current. So if you're running very, very high loads and you run it through the dimmer, it's going to work, but you'll lose some energy to heat in that copper trace. It's just not necessary.
We got another question here. For the 50 white LED, you're cooling the LED itself with a fan. Does the lumen dim micro also need active cooling? In this situation, we didn't need to because I had enough open airspace within there. With this orb, with the regular DMX picks and the orb, I actually put spacers in before the cap goes on. So there's a little bit of air movement within inside there because this actually generates a significant amount of heat. Not the DMX picks, but the actual LEDs themselves generated enough heat that you can actually ASMR, you can hear it. That it doesn't fit very well anymore. It actually started to misshape the PLA 3D print when we were down in Atlanta, and this was running for 8 hours a day, 2 days straight. It wasn't designed to do it. It was meant to be on stage for 3 minutes at a time.
It's a funny little trick, when we have to design products that will run through an 8 or 10 hour trade show presentation, that typically represents a vastly harder work job than the typical customer use. So, we designed it needing it to work in a case that is really ultimately fairly extreme. So we take this stuff into account.
And like the Joseph coat, it took 4 6-volt batteries to power the coat. There are 2 milliamp hour batteries, 2000 milliamp hour batteries in there. I can, timing wise, we can make it the song length of the main song, about his coat, plus about 45 seconds. That's all the time that we can make it, and that's all the weight that we could put into the coat with the dancing that had to happen. They take the coat off, they slam the coat on the ground, they twist the coat, they tear the coat, they beat the daylights out of the coat. And so we had to balance, how much battery power do we put in there? How long can we make it? Then, like right now, I am not on battery power because it's not set up to run that long, right? I have a 5-volt power supply sitting on the floor that's providing power to that and to the elevator there. And those things are things you just have to balance within there. Is what is your weight capability? The nice thing about putting these batteries in the fire pit is it gave it weight. So when they carry it on stage during transition, it gave it some weight. So the rocks and the wood actually looked heavy.
So an advantage for the fire, a disadvantage for a dress.
Yeah, exactly. Exactly. So, questions, folks? I see a lot of good chatting going on. And this live stream will go up on YouTube once we have a chance to go through and just make sure everything's all good, and it will process through the system. So it will be accessible later on if you got to go do hang or do a call or something.
Yeah. I'm sure you all know too, we're very accessible. So if you go to our ticket system or if you send us an email, those are the best way to reach me. Of course, you can always phone, and Amy and Anna are there, and I can do phone calls usually by scheduling, and it never takes very long. If it's pressing, you can, Anna and Amy are pretty good at getting me out of whatever I'm in and on the phone with you when it's a really urgent matter. But we're very accessible and very easy to reach, and I love to talk to you about the projects that you're working on. So. You don't have to figure out all the problems yourself. Sometimes Chris comes in also and helps a little bit with that. We are more than just the products. We're here to help you make them work and solve the problems that you face.
Got a question. Chris, what's your channel? I'm interested in your use cases. You can find the tutorials that I make on RC4 Wireless's channel itself. So a lot of the stuff is on there. I do have a YouTube channel that I kind of stopped posting on because I started putting everything on RC4's channel. But you can find me underneath Chris Wood and whatnot there. But all the tutorials will end up on RC4's site and so forth. We have the campfire coming up. We have our animatronic eyeball Harvey. A video is coming out with him soon. He went down to Atlanta with us for the trade show down there at Trilla Studios. And unfortunately, on the way back, his neck snapped. So we just finished printing a brand new body for Harvey. It's all out of carbon fiber PLA filament. So he should be good to go. So we got a video coming from Harvey. We've got a video going through on how to light up costumes like this and the techniques that go inside of how to attach the LEDs so that wardrobe doesn't hate you. That's a really important thing. If it's cool to put LEDs inside, but if you can't get them out to repair them and they have to, let's say you stitch the LEDs in, that wardrobe's typically not very happy about having to pull all that back out and restitch everything. And so we got a video coming out on that. This elevator thing, got a video coming up on that. And so, yeah, we got stuff coming down the road here. And yeah, I forgot to mention, I'm sure everybody's familiar with the X-Stick here as your dongle for the 2.4 gigahertz range. RC4 has moved on to the next generation here. So it looks a lot like the 900 megahertz version. It does have a little bit more power than the regular X-Stick does. So it can get a little more reach when you're using your computer. And from my experience of using it in the shop so far and in the field, it's pretty fantastic. Jim, do you have anything to add about that? Sorry, I caught you right in the middle of chat typing.
Well, I was just going to pop this up on the screen. What you're talking about is the dongle for RC4 Magic. So that doesn't work with Lumen Dim devices. You did already mention it looks a lot like the 900 megahertz product, and that's true. The identical device for the 900 megahertz RC4 Magic also exists. And yeah, originally, the components that were in the X-Stick became unavailable, and that's the reason that we redesigned and went to an external dongle like this. But all the feedback has been so positive about the higher RF power and range that we've decided to just stay with this because it's much, much easier for you to do, the intent of Commander to be able to get into the devices and the props as they are already out on stage. You don't have to bring them close to the computer. And there was some deficiency in range with the little X-Stick, and that's gone when you use the new higher power dongle.
Yeah, when I would have a lot of transmitters on stage on large shows, I would have to carry my laptop a little bit closer with the X-Stick on there. With these new dongles, I can stand center stage, and it's pretty much effortless to connect. I'm thoroughly enjoying that ability there.
You know what? I don't think we should say this is the last one of these. I think we should do some more of these.
Yeah.
I do appreciate everyone coming out, and think about the questions that you'd like us to answer in a future live stream, and I would like to address them then too. And in person, we'll just email you back or call you back or whatever. But I like to kind of spread the love and let more people know about some things when we can. Thank you all for coming. It's been a great turnout. I appreciate it very much.
And if you find there's anything you want a tutorial on, let us know. So if you have a question of, I need to do a butterfly that flaps its wings inside of a jar, can an RC4 unit do that? Let us know. Maybe we can make a tutorial out on how to do something like that.
Did you make that work, Chris? Because that's a real prospect, right?
So it is a project that has been put aside because it got incredibly frustrating. So there's a butterfly flap inside a jar. Everything's ran through the branches, but there's a ball joint to make the wings move, and that ball joint keeps breaking. And I know how I have to do it. I just don't have the capabilities of making it right now. So I need to make it out of metal, that small joint, and it's coming. Yeah. I promise that one's coming. The fireflies in a jar, things like that. DMX Pix Micro, perfect for making fireflies in a jar. Get little small pixels. They get, really small pixels. You can get down to 1.5 millimeter or smaller pixels. Run that to a DMX Pix, and now you have small fireflies inside there. It works really well. But yeah, let us know. Let us know if there's tutorials you want to see. We'll look at some more live streams. Maybe we can do one about lighting up costumes. We'll look at doing the live stream for the DMX Picks. Yeah, it's been fantastic virtually chatting with you all. And
Jesse in Australia, I did see your comment that these early mornings for you are going to difficult, especially. You're certainly probably not going to be in the state of mind to do a like hands-on follow along, pixel operating tutorial at 5:30 in the morning. But many of these topics, the live streams will be available later. And also, Chris has been doing a great job. If you go and look at what he's been posting for the last few months, a lot of the subjects and more coming, you can watch them anytime. So let us know what subjects you want us to tackle, and we'll get right on that.
All right. Should we call it?
Yeah. Thank you all again. It's been a real pleasure at our end with all the feedback and everything. So thank you.
Have a great morning, great night, and great evening, I think, and a great day. I think we got all parts of the country there, or world, I mean.
Yeah.
So, cool. All right. We will talk to you later. Thanks, folks.
Yeah. Bye-bye.
Thanks for joining RC4 Wireless. Make sure you drop a like, ring that bell, and subscribe to the channel to stay up to date with new tutorials coming out and how-to videos.